Dear students, welcome. Today I am going to take a class on vector calculus. This chapter is included in the fourth semester mathematics honors, multivariate calculus. We have already done 7 classes on vector calculus. This will be our 8th class on vector calculus. Today I shall try to solve these problems. The problems have already been written in the board. Number 1, prove that divergence of gradient r to the power n equal to this. We have to find the divergence of gradient. You know the gradient of a scalar function, r to the power n is a scalar function, is a vector function. And divergence of that vector function will be a scalar function. Therefore, the result will be in scalar quantity, will be a scalar function. Result will be a scalar point function. Now, first, gradient of r to the power n. Question number 1, gradient of r to the power n. You know that the gradient of fu equal to f dash u gradient of u. Gradient of, I told you that gradient of fu equal to f dash u gradient of u. F dash u gradient of u. Now, gradient of r to the power n. Gradient of r to the power n equal to f dash this one, f dash u, u means this one, into gradient of r. Therefore, f dash u means n r to the power n minus 1. The differentiation of this into gradient of differentiation of this and gradient of r. Gradient of r. Differentiation of this and gradient of r. What is gradient of r? Now, let me write like this. Gradient of r. What is gradient of r? This is equal to I cap delta r del r by del x plus j cap del r by del y plus k cap del r by del z. Gradient of r will be this. Now, r square is equal to x square plus y square plus z square. Now differentiate partially with respect to x. You will definitely get this one. Differentiate partially with respect to x. Twice r del r by del x equal to twice x, and other two terms will be equal to 0 because you are differentiating partially with respect to x. Therefore, del x of y square will be equal to 0, del x of z square will be again 0. This means del r by del x equal to x by r. X by r. Similarly, del r by del x, similarly means if you differentiate this with respect to y partially, then you will get del r by del y. This will be equal to y by r, and del r by del z will be equal to z by r. Therefore, gradient of r, therefore gradient of r will be equal to x by r I cap, x by r I cap, y by r j cap plus z by r k cap. This is equal to, if you take 1 by r common, and in the bracket you will get x I cap plus y j cap plus z k cap. This is equal to 1 by r vector. This is equal to r vector. Therefore, gradient of r will be equal to 1 by r vector. You should remember this. Gradient r equal to 1 by r vector. This is equal to n r to the power n minus 2 r vector. you will get n r to the power n minus 2 r factor. Gradient of r to the power n equal to this. Now, therefore, divergence of gradient of r to the power n should be equal to divergence of n r to the power n minus 2 r vector. It will be like this. Now, divergence of the product of a scalar and a vector, this is equal to, from this you will get n r to the power n minus 2 divergence of r vector plus I am writing here gradient of n r to the power n minus 2 dot, it will be dot r vector. The important theorem I have applied this phi a vector. Suppose this phi is a scalar, a is a vector quantity. Then the divergence of the product of a scalar and a vector, this is equal to phi divergence of a vector plus gradient of phi dot a vector. This formula has been applied here. Now, you see, we have applied this. Divergence of r vector. Divergence of r. What is the value of divergence of r? This is equal to 3. How? Divergence of r vector. Divergence of r equal to I cap del x plus j cap del y plus k cap del j dot x I cap plus y j cap plus z k cap. This is equal to del x by del x, del y by del y plus del z by del z. This is equal to 1 plus 1 plus 1 equal to 3. Divergence of r vector, this is equal to 3. R vector equal to 3. And the gradient of this R vector is equal to 3. Therefore, also you may find the this one gradient of this. Now, therefore you may write, therefore divergence of gradient of r to the power m should be equal to n r to the power m minus 2 into 3 plus, what is the gradient of this? The same formula. Gradient of f equal to f dash gradient of e. Therefore, differentiate this with respect to n into n minus 2 r to the power n minus 3 into gradient of r dot r vector. You will get this one. Now, this is equal to thrice m r to the power n minus 2 n into n minus 2 r to the power n minus 3 gradient of r equal to 1 by r vector. 1 by r vector. Dot r vector. Dot r vector. This is equal to thrice m r to the power n minus 2 n into n minus 2 r to the power, it will be n minus 4. It will be r to the power n minus 4. You may write r vector dot r vector. We have applied what we have applied. Since it is of the form n a vector up to this up to this, it is a scalar quantity. A vector dot B vector. This is equal to M A dot B. A dot B. This has been applied. We have applied this. This has been applied. What is R vector dot R vector? Magnitude of R vector dot into magnitude of R vector into cos of angle cos of 0. Cos 0 equal to 1. This is equal to R square. This is equal to, from this, thrice n R to the power n minus 2 n into n minus 2 R to the power n minus 4 R square. This is equal to thrice n R to the power n minus 2 n into n minus 2 R to the power, it will be n minus 2. N minus 4 plus 2, it will be n minus 2. This is equal to n into R to the power n minus 2. It will be 3 plus n minus 2. 3 plus n minus 2. This is equal to n plus 1. N into n plus 1 R to the power n minus 2. N into n plus 1 R to the power n minus 2. We have proved the number 1. Just we have proved number 1. Now come to the question number 2. If f and g are two scalar point functions, then we have to prove the divergence of this. R to the power n minus. F and g are two scalar point functions. Divergence of f, it stands for gradient of g. Gradient of g. We have number 2. We have gradient of g. This is equal to. This is equal to gradient of g. This gradient of g. This is equal to this gradient of g. Equal to. I cap del g by del x plus j cap del g by del y plus k cap del g by del z. Del g by del z. Gradient of g means this. F of gradient of g. F of gradient of g. This will be equal to I cap f del g by del x plus j cap f del g by del y plus k cap f del g by del z del g by del z del g by del z. Now divergence of this, divergence, therefore divergence of f gradient of g should be equal to, if a vector equal to, suppose a vector is equal to a1 I cap, a vector is equal to a1 I cap plus a2 j cap plus a3 k cap, then divergence of a vector equal to del a1 by del x plus del a2 by del y plus del a3 by del z. Therefore, it will be equal to del x of f del g by del x plus del y of f del g by del y plus del z of f del g by del z. You will get this one. Now, this is equal to f del square g by del x square plus del f by del x del z by del x plus f del 2 z by del y square plus del f by del y del z by del y plus f del 2 z by del z square plus del f by del z del z by del z. You will get this one. You will get this one. Now, this is equal to f del 2z by del x square plus del 2z by del y square plus del 2z by del z square. This one, this one, this one. Plus del f by del x, del z by del x. Plus del f by del y, del z by del y, del f by del z, del z by del z. This is equal to f delta square, del square. Z plus. This can be expressed in the form. Can I write like this? I cap delta f by delta y z cap plus delta f by delta z k cap dot dot. After this it is dot dot. Let me write here dot del z by del x I cap plus del z by del y z cap plus del z by del z k cap. Can I write like this? Because a1x plus a1x plus a2, because you see a1 I cap plus a2 z cap plus a3 k cap dot b1 I cap plus b2 z cap plus b3 k cap should be equal to a1 into b1 plus a2 into b2 plus a3 into b3. Here it is of the form a1 b1 plus a2 b2 plus a3 b3. It can be expressed in the form this one, this dot this. We have written this one. Now this can be expressed as this is equal to f. It is nebula square z. Nebula square z plus it is nothing but gradient of f. It is gradient of f dot gradient of z numerically. In total, you see, it stands for del square by del x square plus del square by del y square plus del square by del z square. If z is a scalar function, then total this is again a scalar function. If it is a vector function, then this nebula square, that vector function will always represent a vector function. Since z is a scalar quantity, scalar point function, therefore delta square nebula square g is a scalar function. These two are vector function. Gradient of a scalar function is a vector function. The dot product of the vector function is again a scalar function. Therefore, it is scalar, it is scalar. Therefore, divergence of a vector function will be always a scalar function. This is a scalar function, and the right hand side is also a scalar function. We have proved the question number 2. Question number 2. Let us come to the question number 3. Let us come to the question number 3. What is it? Question number 3 is very easy. Gradient of phi is a scalar function. Gradient of phi, you should always find the curl of a vector quantity and the result will come in a vector function. Curl of a vector function is always a vector function. It is zero, therefore we have written the zero vector function. Now you see, we know that. Number three, we know that. Curl of phi a vector, this is equal to phi of curl a vector plus gradient of phi cross a vector. Gradient of phi cross a vector. Gradient of phi plus a vector. Therefore, curl of phi gradient of phi equal to phi curl of gradient of phi plus gradient of phi cross gradient of phi. Remember a vector identity. Curl of gradient of a scalar quantity is always zero vector. This is equal to phi zero vector. We have already proved this vector identity. Curl of gradient of phi is always zero vector. And gradient phi is a vector quantity. The cross product of two vector function, cross product of two vector quantity up to equal vector is zero vector plus zero vector. Since curl of gradient of phi, this is equal to zero vector, is a vector identity, and the cross product of two vector quantity is zero vector, and this is equal to zero vector. Gradient phi cross gradient phi, this is equal to zero vector, is equal to zero vector. So just we have proved the question number 3. Now come to the question number 4. Question number 4. Prove that this is divergence of R gradient of 1 by R cube equal to this. Gradient of R cube. Number 4. Come to question number 4. We have gradient of 1 by R cube equal to, it is gradient of 1 by R cube, scalar function. Gradient of F u equal to F dash u, gradient of u. This is equal to the differentiation of 1 by R cube, means differentiation of R to the power minus 3 will be equal to minus 3 R to the power minus 4 gradient of R. We have already proved in question number 1 that gradient R is equal to 1 by R vector. This is equal to minus 3 R to the power minus 4 1 by R vector. This is equal to minus 3 R to the power minus 5. It will be minus 5 R vector. Because it is 1 by R vector. Therefore, R into this. R into gradient of 1 by R cube equal to minus 3 R to the power minus 4. It will be definitely this. Multiplied by R to the power minus 5 plus 1. It will be R to the power minus 4. Therefore, divergence of this divergence of R, the gradient of 1 by R cube, equal to the divergence of minus 3 R to the power minus 4 R vector. Now, this is equal to, you see, this is a scalar quantity. Minus 3 R to the power minus 4 is a scalar quantity. R vector is a vector quantity. Therefore, it is of the form divergence of phi A vector. It is of the form. Therefore, it will be phi into divergence of R vector. Divergence of R vector. Plus gradient of minus 3 R to the power minus 4 dot R vector, since divergence of phi A, this is equal to phi divergence of A plus gradient of phi dot A vector. We have applied this vector identity, important vector identity. Divergence of phi A vector equal to phi divergence of A plus gradient phi dot A vector. Now, this is equal to minus 3 R to the power minus 4. Divergence of R vector equal to 3. Means del x by del x plus del y by del y plus del z by del z equal to 1 plus 1 plus 1 equal to 3. It is 3 plus, again it is of the form gradient of f u equal to f dash u gradient of u minus 3 into differentiation of r to the power minus 4 minus 4 R to the power minus 5 gradient of R dot R vector. This is equal to minus 9 R to the power minus 4 R to the power minus 4 plus 12 R to the power minus 5. What is gradient R? 1 by R vector. R vector dot R vector. It is 12. This 12. That's right like this. Because gradient R equal to 1 by R vector. Therefore, this is equal to minus 9 R to the power minus 4 plus 12 R to the power minus 4 R vector dot R vector. Because since M A vector dot B vector equal to M A dot B, M A dot B, this formula has been applied. It is scalar quantity M into A vector dot B vector. This M, take it outside and put it as bracket. Number 1. It is r to the power minus 5, 1 by r, means r to the power minus, not minus 4, it will be r to the power minus 6. R to the power minus 5 into 1 by r, means r to the power minus 6, it will be r to the power minus 6. This is equal to minus 9 by r to the power 4 plus 12 r to the power minus 6, it is r square. This is equal to minus 9 by r to the power 4 plus 12 by r to the power 4. R to the power minus 6 plus 2 r to the power minus 4, 1 by r to the power. This is equal to 3 divided by r to the power 4. Therefore, we have proved the question number 4. We have proved question number 4. Go ahead, you have understood this and You have noted down. Noted. Alright. We have put question number 4. Come to the question number 5. Question number 5. Just note it. Question number 5. Gradient of 5. Gradient of 1 by r. This is equal to minus r to the power minus 2 gradient of r. Gradient. Gradient of fu equal to f dash u gradient of u. The differentiation of 1 by r with respect to r will be equal to minus r to the power minus 2. This is equal to minus r to the power minus 2. It is 1 by r vector. This is equal to minus 1 by r cube r vector. One by r cube r vector. Therefore, a vector dot this gradient of 1 by r equal to a vector dot minus 1 by r cube r vector. Same case, this is equal to minus 1 by r cube a vector dot r vector. Since a vector dot mb vector equal to m a dot b, because minus 1 by r cube is a scalar quantity, treat it as m. Suppose this is equal to m, a vector dot mb vector. Just m, take m outside, means 1 by. Therefore, which can be written as minus a vector dot r vector divided by r cube. Dot product of two vector quantities is a scalar quantity. A vector dot r vector is a scalar quantity. As a whole, all terms will be scalar. Now, we have proved the question number 5. You see, in question number 6, we shall apply this one. We shall apply this one. Question number 6. We have proved question number 5. Now, question number 6. Last question. Here. Question number 6. A vector we have. A vector dot gradient of 1 by r should be equal to minus this one, a dot r. Divided by r cube. A dot r divided by r cube. A dot r divided by r cube. Therefore, gradient of this should be equal to gradient of minus a vector dot r by r cube. Gradient of this. Let me remind you. Gradient of f into g to scalar. Gradient of f into g. F and g are scalar functions. Then it will be equal to f gradient of g plus g gradient of f. G into gradient of f. I am going to apply this gradient of the product of two scalar quantities. Gradient of the product of two scalar quantities. One is minus 1 by r cube and the other is a vector dot r vector. This is equal to minus 1 by r cube gradient of a dot r plus a dot r plus a dot r gradient of minus 1 by r cube minus 1 by r cube. You may write in the bracket since gradient of the product of two scalar quantities equal to f gradient of z plus z gradient of f. Z gradient of f. We have applied this one. Now you may write here gradient of a vector dot gradient of 1 by r equal to this. Suppose this is number 1. Now gradient of a dot r. What is gradient of a dot r? Suppose let a vector is a vector a1 I cap plus a2 j cap plus a3 k cap. R vector equal to x I cap plus y j cap plus z k cap. It is like this. Therefore, a vector dot x dot r vector. What is this? A dot r will be equal to a1x plus a2y plus a3j. a1x, a2y plus a3j. Therefore, gradient of a dot r, this is equal to gradient of a1x plus a2y plus a3j plus a3j. Gradient of this. This means which is equal to I cap del x a1x plus a2y plus a3j plus j cap del y of a1x plus a2y plus a3j plus k cap del j a1x plus a2y plus a3j. This is equal to, what will be this? a1. I cap, it will be a1. This is 0, this is 0. Partial differentiation of a2y plus a3j will be equal to 0 with respect to x. Similarly, j cap, it will be 0 a2 plus 0. It will be 0 plus 0 plus a3. K cap a3. This is equal to a1 I cap plus a2 j cap plus a3 k cap. This is equal to a vector. Therefore, gradient of this is equal to a vector. We have got a gradient of a vector dot r vector is equal to a vector simply. Now, from 1 you will get, from 1 you will get therefore 1 implies, from 1 you will get the gradient of a vector dot this gradient of 1 by r should be equal to minus 1 by r cube. It will be a vector plus a vector dot r vector gradient of this. Same formula, gradient of fu equal to f dash u gradient of u. Minus 1 minus 3 r to the power minus 4 gradient of r. Gradient of r. This is equal to minus 1 by r cube a vector plus a vector dot r vector into 3 r to the power minus 4. Gradient of r is equal to 1 by r vector, 1 by r into r vector. This is equal to minus r cube a vector plus 3 a vector dot r vector r to the power minus 5 r vector. You will get this one. You will get this one. Now b vector dot this. The last. Therefore b vector dot this. Dot gradient of a vector dot gradient of 1 by r. B vector dot this. Suppose this equal to b vector dot minus 1 by r cube. A vector plus 3 a dot r to the power minus 5 into r vector minus 5 into r vector. Now dot product is distributive. Since the dot product is distributive, therefore you may write like this. Dot product is distributive. Since the dot product is distributive, you may write dot product is distributive. Now, this is equal to minus 1 by r cube b vector dot a vector plus from this to this a scalar quantity. Thus, write the scalar quantity r to the power number once again 3 a vector dot r to the power minus 4. It will be r to the power minus 5. R to the power minus 5. It is r to the power, not r to the power 5. You should write r to the power minus 5. R to the power minus 5. Up to r to the power minus 5. R to the power minus 4 divided by r means r to the power minus 4 minus 1. R to the power minus 5. This one. R to the power minus 5 b vector dot r vector. You may write like this. Since here you see a vector dot mb vector, it is of the form a vector dot mb vector. Just put the m outside and a vector dot b vector. Since this one, because here it is of the form a vector dot mb vector. Write this, and here also from this to this means 3 is a scalar quantity, a vector dot r vector is a scalar quantity, r to the power minus 5 is again a scalar quantity. Thus this is m. You write this m into a vector dot b vector like this. Since this one, a vector dot this is equal to m into this. A vector dot m into this equal to m b vector equal to m into this. This has been applied in both of these two. In both of these. Now, this is equal to, write this first 3 times of A vector dot R vector into B vector dot R vector. All are scalar quantities divided by R to the power minus 5 can be written as divided 1 by R to the power 5 minus A dot B equal to B dot A divided by R cube. Divided by R cube. B dot A equal to A dot B. Commutative, the product is commutative, therefore you may write like this. You see all quantity, this is a scalar quantity, this is scalar, all scalar. A dot B is a scalar quantity. Therefore we have solved this. A and B are constant vectors. These A and B are constant vectors. Therefore, we have proved the question number 6 also. Dear students, today I have solved 6 questions. In the next class, we shall discuss and we shall try to solve some more problems on vector calculus. Today, I want to stop here. Thanks for attending the class. Thank you very much.